Hi guys. So what we are doing here for 15 minutes is kind of wrapping up this discussion of some chemical principles focused around ethanol and gasoline or octane as our activities, our enrichments have focused on. So last week I asked you to balance these equations for gasoline and ethanol, and these are what we call combustion reactions, as you've already learned too. And a combustion reaction is where you take a hydrocarbon, which both octane and ethanol are, and you react it with oxygen to end up with carbon dioxide and water. Now, this illustrates a couple of things. I'm going to talk about this from some, global perspectives too. So, first of all, the emission of carbon dioxide. We've talked about this quite a bit throughout the year, off and on. The emission of carbon dioxide is a bad thing, mostly depending on your point of view, but it's causing global climate change, it's causing global warming, and so we've talked about the need to reduce our dependence on fossil fuels to alleviate this problem. Now, some people talk about ethanol as a cleaner fuel alternative, but as you can see, a combustion is a combustion. As long as you're burning a hydrocarbon, it doesn't matter what it is, it's going to emit carbon dioxide. So it's not like burning ethanol or burning E85 instead of regular gasoline is not putting as much carbon dioxide into the atmosphere. That's really not true. It is true that gasoline has other impurities in it, like gasoline has some sulfur in it, and also you get nitrogen emissions always because in air is a mixture of nitrogen and oxygen and some other trace gases, but there's actually a lot more nitrogen in the air than oxygen. Now, nitrogen is a lot more stable gas than oxygen, so nitrogen does not react as readily in an engine, but when you suck air into an engine, you're pulling in nitrogen as well as oxygen. And so some of that nitrogen will actually react under the high pressures and temperatures inside of an engine, and you'll end up with nitrogen oxides, which are somewhat toxic gases, and when they get into the atmosphere, they can react with water vapor in the atmosphere and produce like nitric acid rain. And so those nitrogen and sulfur compounds were largely responsible for a lot of smog and acid rain issues in large cities before the Clean Air Act was passed. So when we talk about ethanol being a cleaner fuel, it does not have the sulfur content of gasoline. You do still have the nitrogen issue, because the nitrogen's in the air. You can't filter that out. I mean, when you suck air into the engine, you're pulling in nitrogen and oxygen. But with relation to what we were talking about last week, or what you looked at last week, as I've said, these are both combustion reactions. However, when you balance them, you see that they balance very, very differently. And in cars, this is really important. So when gasoline burns, the ratio of fuel to oxygen turns out to be 2 to 25 or 1 to 12.5. Now, for some purposes, in a car, the ratio of the air to fuel mixture is actually a little higher than that. It's actually like 1 to 14.6 or something like that. And that's partially because you've got to allow for the amount of nitrogen that's going to react so that you're ensuring that you have enough oxygen there to completely combust the fuel. But ethanol, on the other hand, is a much different ratio of oxygen to fuel. It's only a 1 to 3 ratio of fuel to air. Now, in a car, cars are very interesting chemical machines. Okay, you've got fuel delivery systems that set the amount of fuel. You can't really control the amount of air that's coming into the engine. The air is just determined by the displacement of the cylinder. So every time the piston draws down, you're going to take a set amount of air into the piston chamber, into the combustion chamber. So you can't change the air, but what you can change is the amount of fuel that's being delivered into the chamber to combust, to react with that air. So it needs a very different amount of fuel between ethanol and gasoline. So to answer the question of could you run a normal car that isn't meant for it on E85? The answer is probably not. It might run, but it would run terribly because the fuel mixture, the fuel to air mixture, is not set up for ethanol. So to have a car where you could put gasoline in it one trip and put ethanol in it another trip, you have to have a car that somehow has a way to vary the air fuel mixture. Now, to get into just a little bit of mechanics on you, and I'm not a mechanic, I just know the very basis of this. Okay, in old cars, you may have heard of a carburetor. Okay, and all like small engines still have them. So your lawnmowers, your ATVs, well, maybe ATVs, but lawnmowers definitely have carburetors. They have basically a little fuel bowl, and it's got what we call metering rods in it that set the amount of gas that's drawn into the cylinder on each piston stroke. So you adjust the metering rods to change your air fuel mixture. If you've got too much fuel for the air that's in the cylinder, we call that a rich mixture. And if you've got too little fuel for the air that's in the cylinder, we call that a lean mixture. Okay? So if you had a car that's set up to run on gasoline, and then you all of a sudden put ethanol in it, your mixture is going to be much, 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 much too lean. There's going to be too little fuel for the air that is in the cylinder if you didn't have a way to change the amount of fuel being delivered to the combustion chamber. But with modern cars, they all are fuel injected, which means there aren't carburetors. There's an individual injector on each cylinder that delivers a certain amount of gas before each upstroke or before the compression stroke of the piston. And that's determined by the computer, basically. So it's computerized, it's not mechanical. And still, it doesn't necessarily have the ability to adapt. So in order to do that, you've got to have a car that has what's known as a flex fuel sensor. Okay? Not letting me change it. There we go. A flex fuel sensor. So they used to have these badges on them. I'm not sure that all flex fuel cars do anymore, but you have to know whether a car is able to do this or not. So if you see this badge on it and it says flex fuel, then what that means is that there's an extra sensor that's inserted into the fuel line, and the sensor measures the capacitance of the fuel. Now, we know from back when we did the conductivity experiments, ethanol does not conduct electricity. And we didn't test gasoline, but gasoline does not either, which is good because, I mean, you wouldn't want an actual spark crossing your fuel line inside. That's not what's happening. But it measures what's called the dielectric constant of the fuel. And these are physical properties of insulators, is to what degree they will polarize when a current is run across them. So there's a difference in the dielectric properties of ethanol and gasoline. And so the capacitor is basically like a metal cylinder with another metal cylinder inside it and a gap between the two. And so as the fuel runs through the fuel line, it runs in that gap between the two metal cylinders, and a small current is passed from one cylinder to the other. And that allows the computer to measure the dielectric current or the dielectric constant in the fuel, and that allows the computer to tell how much or what percentage of ethanol is in the fuel. And then that computer talks to another computer that adjusts the fuel injectors and says, if there's more ethanol, we need to inject more fuel into the chamber so that the mixture is not too lean for the car to run on. So therefore, the flex fuel sensor can adapt to any percentage of ethanol that's in the fuel by adjusting the air fuel ratio that's coming into your engine. Okay, and that's how it's able to run. So again, could we answer that question? Could a car that is not meant to run on ethanol run on ethanol? Maybe, but you have to, it would run terribly unless you've got a way to adjust your air fuel mixture, because it would be much too lean if you're all of a sudden taking a car that's set up to run on the ratio for gasoline and putting ethanol into it. You know, the last point I guess I kind of want to make with ethanol, because some other people have commented on this too, is where are we at with ethanol? Unfortunately, right now, our ethanol industry is really, really hurting because of the low price of oil, which makes gasoline so cheap. I mean, one of the attractive things about E85 is usually the price, and so right now it's difficult with gasoline being so cheap. It's difficult to justify buying E85. Another thing is, the industry, flex fuel cars 5 years ago were really, really popular. And unfortunately, today, a lot of the large manufacturers have gone back away from it because there weren't a high enough percentage of consumers using it, and E85 was not readily available everywhere across the country. I mean, it typically is in Iowa, but we produce a lot of ethanol in Iowa. You can get ethanol blends everywhere across the country up to the 10 or 15%, but E85 was not really available all across the country. So, they went from having flex fuel being a pretty standard option 5 years ago to where today most of the new vehicles that are coming out are once again only set up to run on gasoline. And if you wanted to get one that can run on E85, then it's usually an add-on option that you have to pay a little extra for. I mean, it's not a lot, but it's like a couple hundred or a few $100s to get that flex fuel sensor in the car. And so, unfortunately, that's uh, a little bit of a detriment to the ethanol industry, that they're not producing as many flex fuel cars these days. But ethanol, the other thing about it is, of course, you have to use the corn grain to produce the ethanol, and that competes with corn being used to make food. So, sort of the holy grail of ethanol is what we would call cellulosic ethanol, which means you're actually using enzymes to ferment the stuff in the corn plant or any plant that's not used for food. So, the stalks, the stems, the chaff, and so you can make ethanol from that, which does not have sugar in it, but it does have material in it, the cellulose, that can be converted to ethanol, but it's a different process. It takes specialized enzymes. It's a lot more difficult. And so there is one plant in Iowa that was producing this, but unfortunately, I think it's been shut down right now, at least through this crisis. So progress is being made there, but we're not anywhere up to producing large scale quantities of cellulosic ethanol. Well, all right, ladies and gentlemen, I hope you learned something, and I hope that you've learned something about balancing equations and types of reactions, and a little bit more about how your car works, because they're pretty cool mechanical chemical machines. So we'll see you next week. Thank you very much.